Okay. He gives you a statement, guys, and he wants the null and the alternative. This is how I started chapter 7, stating the null and the alternative. He says variation means a standard deviation, more than the old model, and the old model is 50, guys, so it's more than 50. So do you want to write the null and the alternative hypothesis? It will be this. Sigma is more than 50. This is where the claim is. And that one will be sigma less than or equal to 50. That's a null and the alternative. If you ask me again, how did I figure out it's sigma? It says variation means standard deviation. More, that's a more right here, than 50. Number 2, the null and the alternative hypotheses are given. Determine whether the test is left-tailed, right-tailed, or two-tailed. Well, since HA, guys, is greater than, greater than means right-tailed, less than it's a left-tailed, and not equal to is two-tailed. So this is a greater than, it is a right-tailed. And not a p hat, it's a p, we're testing p. You see here, there is a p hat, you don't want to select this one. That's the answer to this part. The mean repair bill of cars is greater than 140, right? The null and the alternative hypothesis. That should be easy, guys. It's the mean greater than 140. And greater than must be in the alternative. So that will be HA. And HO would be mean is less than or equal to 140. Now, let me just bring one thing to your attention. If you check the answers in the back for number 3, for example, let me show you. It says equal here, but remember what I said. Those questions I got them from another book. For us, we're gonna use, just less than or equal to. So, but it is correct though. And here we did less than or equal to. And that one is gonna be less than or equal to, because that's a greater than. Number 4. A popular referendum on the ballot is favored by more than half of the voters. Write the null and the alternative hypothesis. Once it comes to ballots, it's a percent. More than half, it means the proportion is more than 50%. So HA will be P is greater than 0.5. That's the claim. And HO less than or equal to 0.5. And again, guys, talking about this, if I say majority, it means more than 50%. If I say minority, means less than 50%. Okay, number 5. I'd like you to help me with number 5. The mean age of principals at the local district is 45.5 years. If a hypothesis test is, so that means, let's write the null and the alternative. HO will be mu equals 45.5. That's what they say, and that's the claim. And you guys, you should be able to tell what the alternative should be, not equal, because equal comes with not equal. Okay. If a hypothesis test is performed, how should you interpret a decision that rejects the null hypothesis? So if this is the null and the alternative, guys, and you reject the null hypothesis, what do you say? Well, you should remember what how I taught you to make the last statement. If you reject HO and the claim is in HO, you guys say there is enough evidence to reject the claim. Why do we say the word reject? Because the claim is in HO. So there is sufficient evidence to reject the claim that mean equals 45.5. Now, guys, we're going to perform a hypothesis test. So everything that I've done so far is section 7.1. For 6, An airline claims that no-show rate for passengers is less than 5%. In a sample of 420 randomly selected reservations, 19 were no-shows. Test the airline's claim. Okay, so now number 6. Once he says percent, guys, you know it's a proportion. So if you want to take a note, this is section 7.4. So HO, number 6. HO and then HA. P is less than 5%. You can do 0.05. That's the claim. And P greater than or equal to 0.5 here. 0.05, sorry. That's it. Make big difference. Okay. N is 420. And X is 19. And alpha is 0.01. Okay, that's all I need. And now, guys, we're going to perform the test. If it is a one proportion, it's called one prop Z test. And let me show you this test on the calculator. You go to stat, tests, and guys, it is number 5. One prop Z test. Watch. You put the value in the null hypothesis, which is 0.05. You put X, which is 19. You put N, which is 420. And you put less than. You must select the alternative. It's always the alternative, whatever the alternative is. And you want to do draw? I can do that. Oh, it's a big p-value. So we're going to fail to reject HO. So Z is negative 0.45, and the p-value is 0.3272. P-value is 0.3272.
So for a test like this on the exam, would we have to write all 5 steps?
Always.
Okay.
Yep. That's greater than alpha. Hold on one second. So 0.32 more than alpha, fail to reject HO. We did this exercise before, guys, if you remember when we did chapter 7. And you say there is not enough evidence at the 0.01 level of significance to support the claim. Why did I use the word support? Because the claim is in HA. To support the airlines claim. And that concludes the question. Any questions, guys, about number 7? So that's a good review of section 7.4. That should be a very good review of section 7.4. Next question. The mean utility bill in one city during the summer was less than 106. Write the null and the alternative hypothesis. That should be easy, guys. HO, HA. Mean is less than 106. That's the claim. And guys, you should know that the other sign should be greater than or equal to 106. That's it. So I might give you some very basic question like this, multiple choice questions to begin the test with. Number 8, the mean number of rushing yards for one NFL team was less than 92 yards per game. So let's write the null and the alternative before we answer the question. Mean is less than 92, that's the claim. And guys, you know, mean greater than 90 or equal to 92 will be HO. If a hypothesis test is performed, how should you interpret a decision that failed to reject the null hypothesis? Remember, guys, when we fail to reject the null hypothesis, we say there is not enough evidence. So let me look for where it says there is not enough evidence. So it's on between B and D. Since the claim, guys, is in HA, I need to look for the word support. Which one has the word support? So it's not B, guys. It must be what? D. Does that make sense? An easy way to figure out the answer? That's the easy way to figure out the answer. Number 9. A shipping firm suspects that the mean life of a certain brand of tire used by its trucks is less than 39,000 miles. Okay, so let's do that. Number 9. They suspect that the mean lifetime is less than 39,000. Okay, so let's write down the null and the alternative. And mean is greater than or equal to 39,000, and that's the claim, guys. To check the claim, the firm randomly selects and tests 18 of these tires. So N is 18. And gets a mean lifetime of 38,350. X bar is 38,350. With a standard deviation, since he didn't say population standard deviation, guys, that's S. 1,200 miles. At alpha equals 0.05. Test the shipping firm's claim. Okay. So this is a t-test. Again, the difference between t-test and z-test, guys. A z-test, when he gives you population standard deviation, since he gave us S, he didn't say population standard deviation, it's a t-test. So just a t-test. So that's, we're reviewing now, guys, section 7.3. Right here. Okay, let's do that.
Mr. Bazzi,
Mm-hmm.
are you gonna provide us with like a test, like a practice test? In my
This is it. I'm gonna put something like that online as well, but this is the one. That's the one that you're looking at.
Okay, cool. Thank you.
That should be good. That should be very good.
Are we going to be able to have note cards on the test?
1 3x5.
Okay.
So mu0, guys, is 39,000. So please prepare for this one, guys. You will hear from me during the week because I wanted to prepare well for this test. Very important test. 1,200. And what we're doing, guys, now reflects big time on what the test is going to be like. So I'm going to do one exercise at least from each section just to give you a feel what you should expect. Okay, so for this one, guys, before we move to the next calculate, you have to select the null alternative hypothesis, which is less than. So make sure to select it. Look, it's not selected yet. Now it is selected. And then hit calculate faster. So T is negative 2.298. P value is 0.0173. And let's see what alpha 0.05, that's less than alpha, guys. And that's all I need from the calculator. So it is less than alpha. We reject HO. And we say there is enough evidence to support the claim. At the 0.05 level of significance to support the shipping firm claim. So we are saying we support the claim, so their suspicion is right. Any questions about number 9, guys? So that's a very good review of section 7.3. Now we're going to do another review of section 7.3 now, guys, but with data. So we have the data here in number 10. So a local Group claims that the police issue at least 56 parking tickets a day in their area. To prove their point, they randomly select 2 weeks. Their research yields the number of tickets issued for each day. The data are listed below. At alpha equals 0.01, test the group's claim. Okay. Okay, here's what I would like to do here. I would like you to test the claim that the police issue more than 56. So if we state the null in the alternative hypothesis, guys, I changed the wording here. So more than 56, that's the claim. And mu is less than or equal to 56. So let me pause for a second until I enter the data. So we put the data in L1, we go to stat, tests, t-test, it's number 2, guys. Data, I have to select data here. And mu0, don't forget the null value in the null hypothesis, which is 56. My data is in L1. And frequency, don't change it ever. We need a greater than, and then calculate. So T is 1.174. P-value is 0.1307, which is bigger than alpha, of course. Fail to reject HO. And you guys say there is not. Why do we say not? Because you fail to reject HO. There is not enough evidence. In the book, sometimes instead of there is not enough evidence, he uses there is insufficient evidence, which is fine. At the 0.01 level of significance to support the group, the local group claim. So we're saying we cannot support them. To support. And why did I put the word support here? Because the claim is right here. Local group claim. All right, guys, so that's number 10. Next question. Number 11. Classify the 2 given samples as independent or dependent. So we're just reviewing chapter 8 now. Pre-training blood pressure of 15 people, post-training blood pressure of 15 people, but we didn't, you know what, here actually, I wanted probably to say the same 15 people. If it is the same, will be dependent, but if they're not the same 15 people, then it will be independent. Let me see what I intended to put. Yeah, so posting of the same 15 people. If I give you this one on the test, I will put the word of the same 15 people. So then they are dependent, guys, because it's the same person before and after. Number 12, classify the 2 given samples as independent or dependent. The scores of 25 students who took a statistics final, the scores of 25 different students, guys. So they have nothing to do with each other. Right away, this is an indication that the sets are independent. Number 13, a recent survey showed that in a sample of 100 elementary school teachers, 15 were single. In a sample of 180 high school teachers, 36 were single. Is the proportion of high school teachers who were single greater than the proportion of elementary schools who were single? Okay, so now guys, this is a two sets. We're gonna do two sample test. It's not a one sample, as you can notice that we have two samples in there. Okay, so let's do, and it's a proportion test because he's talking about the proportions. So let me put this on the index card and solve this problem. Should be very easy question to deal with. So if you want the section, guys, this is section 8.4. And that was 8.1. 8.1. Okay, number 13. HO, HA. Okay, let's see. He's talking about high school teachers. So let's put the high school first. And then elementary. Why did I put it first? Because he started with that first. He says, is the proportion of high school teachers. So I put the high school teachers data as 1. N1 and X1. This is what you need. N2 and X2. Okay, how many high school teachers? We have 180. And 36 were single. How many elementary? We have 100 and 15 were single. Okay, we do a two proportion z-test. Can be one proportion, guys. We have two sets here, so you have to have two proportion. Okay, and let's run the test. What is alpha here? 0.01.
Mr. Bear, why was it a test?
Two prop z-test.
Yeah, why was it a z-test and not a t-test? I don't.
Oh, it's not a t-test because it's not about the mean, it's about the proportion.
Oh,
And actually it's a proportion z-test, not just a z-test, the proportion z-test. You see here the word here, proportion? That's an indicator that we're doing proportion here. So, and so it can't be just a mean. We're not doing mean here, we're doing proportions. So just do the prop z-test. No standard deviation here, no average. It's all X and N only. So we go here. Number 6, guys. Okay, X1, 180. And sorry, X1 is the smaller value, 36. And 1 is 180. X2 is 15. And 2 is 100. And P1, we're testing P1 greater than P2, guys. So P1 is greater than P2, that's the claim. And P1 is less than or equal to P2. And you tell me why? Because he says high school teacher were single greater than the proportion of elementary school teachers. Proportion means a percent. So I got this here and hit calculate, guys. Z is 1.04. P-value, let me show it to you one more time. The p-value is 0.1495. That's big. Bigger than alpha, failed to reject HO. And conclusion, guys, there is not enough evidence at the, what alpha was, 0.01 level of significance to support the claim. We cannot support the claim that the proportion of high school teachers who were single is greater than the proportion of elementary teachers who were single. That is the claim. Any questions, guys? That's number 13. Okay, next one, 14. That's section 8.3. Very important question. A pharmaceutical company wishes to test a new drug with the expectation of lowering cholesterol levels. So they're hoping that it lowers cholesterol levels. 10 subjects are randomly selected and pre-tested. The results are listed below. The subjects were placed on the drug for a period of 6 months, after which their cholesterol levels were tested again. The results are listed below. All units are milligrams per deciliter. Test the company's claim that the drug lowers cholesterol levels. Use alpha equals 0.01. Assume that the population is normally distributed. Guys, you know, when the samples are dependent, when you see like before and after, you have to do the difference D. That's the first thing that you have to do. So 195 minus 180, that's 15. 225 minus 220, that's a 5. 202 minus 210, that's a negative 8. 195 minus 75, that's a 20. 175, 70, that's a 5. That's a 0. That's a 30. That's an 18. That's a 0. And that's a 15. What's the dominant sign, guys, here? Is it the positive or the negative?
Positive.
So now you know what you're going to test. When you set up the null and the alternative hypothesis, guys, you want to test the mean of the difference. We call it mu of D against 0. You put 0 and 0 here. And since we agree that we want the difference to be positive, remember what I said in class on Monday. It's always the opposite of what they say. Lower means decrease. We need to go greater than 0 if we do a difference greater than 0, and that's the claim. If this was higher, then you will do less than 0 here. It will be the total opposite. So the first step, guys, before we do anything, we have to put the data in L1. So let me just do that. Okay, I'm gonna just write them down. 15, 5, negative 8, 20, 5, 0. Don't ignore the 0. Everything gotta be entered there. 18, 0, and then 15. I don't know if the difference is substantial to say that the drug is working. We will see. Okay, and now I'm gonna run a t-test. It's a t-test, guys, for section 8.3, not a 2 sample, 1 sample. It's just D. T-test, data, always data for section 8.3, because you put the data in L1 and always against 0, guys. You must change this 1 to 0 right here. That's a 0. L1, and then we need greater than. Hit calculate. And let's do that on a separate index card. That's number 14. So put D in L1, t-test. Input is data. And for mu0, you're testing against 0 always. So that's very important to be aware of it. So test statistic T, guys. Here you go. It's 2.752. P-value is 0.011. 112. And look, guys, what he gives you also, X bar. X bar means the mean of D. If you add them up and divide by 10, how many values do we have? You will get 10. And S is the standard deviation of D also. It shows on the screen as well. Okay, but I don't need it for this. So what is alpha here, guys? 0.01. It's slightly larger, guys. It happens to be slightly larger. So fail to reject HO. We almost rejected HO. Then you say there is not enough evidence at the 0.01 level of significance to support the claim that the drug lowers cholesterol levels. Although it does lower it, but it's not substantial. That's why we could not say that it's effective. So the results are not significant. Okay, so that's number 14, guys. The next one, 15. This is section 8.2. So you notice I flavor the study guide with one question from each section. A local restaurant claims that the waiting time for its patrons to be served is the lowest in the area. So they claim that they are lower than anybody else. A competitor restaurant checks the waiting time at both restaurants. The samples are listed below. Test the local restaurant claim. Assume population variances are equal, means here pooled is yes. Okay, so this is what we're testing, guys. The restaurant is saying that their mean is less than anybody else. Mu1 is less than mu2, lowest. That means less than. So that's the claim. And you know the null hypothesis will be greater than or equal to. This is a 2-sample t-test. Why not a z-test? Because he didn't give me sigma 1 and sigma 2. He gave me sample standard deviation, sample standard deviation. Okay, let's run the test. That's number 15. HO, mu1 is greater than or equal to mu2, and HA, mu1 is less than mu2. And that's the claim. 2-sample t-test. Let's run the test, guys. Stat. When it is about the mean, in chapter 8, it's either number 3 or number 4. That's it. If it is about the proportion, it's number 6. Okay, not data. I have summary here, guys. X1 bar. Look, just copy what you see here. 5.4. S1, 1.1. Is it? Yeah, 1.1. N1 is 45. Let me go to the other one. X2 bar is 5.7. S2 is 1. N2 is 50. And we need less than. You can see that. And you see pooled, guys, because he says population variances are equal, we assume pooled is yes. It's most of the time it's a no, but in this one I said assume population variances are equal. Hit calculate. And here's the results. So pooled is yes. Here, I'll just put a note for you guys. T is negative 1.392. P-value. I mean, the answers are in the back, but I don't know if they're as detailed as what I'm doing. They were generated by the computer. 3.6. Okay. Okay, so what is alpha here, guys? Alpha is 5%. That's bigger than alpha. You fail to reject HO. And you say there is not enough evidence at the 0.05 level of significance to support the claim.
I have one question.
Mm-hmm.
Can you explain one more time about pooled, like when it's yes and when it's no?
Yeah, just 1 second. Okay, look, here's how you can tell. You see what it says here? Assume population variances are equal. If you say this, you see this statement, then pooled is yes. If he says assume population variances are not equal, then your pooled is no.
Okay, thank you.
That's the language. Good question. Number 16. A random sample of 8 apples of variety A and an independent random sample of 13 apples of variety B yielded the following weights in ounces. Do the data provide sufficient evidence to conclude that the mean weight of apples of variety A is different from the mean weight of apples of variety B? Use alpha as 10%. Assume that the sample come from normally population that are distributed normally with no outliers, and that population variances are equal. So pooled is yes here. And that's the hint for you guys that it's going to be a 2-sample t-test. Once he mentioned pool, it's a 2-sample t-test, period. Okay, I'm going to pause the recording for 1 second to enter the data. So you're going to put this one in L1 and this one, that one in L2. Let's do that. So I'm going to go to stat, tests, 2-sample t-test with data, guys, here. Now I have the data. I don't have a summary. Okay, it says L3, L4. I don't have it in L3, L4. I have it in 1 and 2. So you just press the second key, guys, and number 1, and then press the second key and number 2. There you go, L1 and L2. And we want to check that they are different. He says different. And pooled, we say it's yes. I might give you the very same question on the test, but to change pooled to no, I said assume population variances are not equal. Just do a no here. And then hit calculate. And here you go. I got the data. 16. HO mu1 equals mu2. HA mu1 not equal to mu2. That's a claim. Very important to identify where the claim is. And we said pooled is yes. So T is negative 1.4223. P-value, guys, is 0.1710. Okay. And that's big. You know what you're going to do now. It's going to be bigger than alpha. You're going to fail to reject HO. We haven't been able to reject HO today, most of the questions. Fail to reject HO, and then you say there is not enough evidence at what's alpha here at the 0.10 level of significance to support the claim that what does the claim say? Okay, to conclude that the mean weight of apples of variety A is different from the mean weight of apples of variety B. You just copy it and paste it, write it down, guys, and that's number 16. Go ahead.
What's the easiest way to determine if the claim is going to be an HO or an HA? I know how to.
Here is it. There, you just read. Look what it says here. Look at that. Read the question. So that's the first thing. Check where. Find out where the sentence that has the question. It's right here. Do the data provide sufficient evidence to conclude that the mean weight of apples of variety A differs? Now, I taught you what different means. Differs means this one. You agree?
Yeah.
And you know this one should be where in the alternative hypothesis, because look, the alternative hypothesis should have this or that one or that one. So
Okay,
if your sign lands B is one of those three, then your claim definitely is in the alternative. In the unlikely event, most of the time, guys, you notice the claim is always in the alternative. If I say test that they are equal, then the claim will be in HO. If I say at least, then the claim will be in HO. If I say at most, then the claim will be in HO. But if it says more than, less than, or not equal to, or different from, then the claim is in HA. Good question.
Thank you.
17. In a survey, 46 of 145 women said that they regularly remember their dreams, while 40 of 140 men said that they regularly remember their dreams. Does this constitute sufficient evidence to conclude that the women are more likely to remember their dreams than men? It's a proportion. I could say that does this constitute sufficient evidence to conclude that the proportion of women is larger than the proportion of men who remember their dreams. How do I know it's a proportion? Because it gives you X and N, X and N. There is no mean, no standard deviation, then you know it is a proportion. So we started with women are more likely to remember their dreams than men. So it's going to be this, guys. P1 is going to be for women, and P2 is going to be for men. And we have X1 and N1 here. X1 is always the smaller number, 46, 145. And then X2, guys, is 40, and N2 is 140. So P1, P1, P2. How did I figure out that the claim is here? Because it says more likely than men, more than men, more than, that's the sign. And that's, and this is 2-prop z-test, guys. Let's run this test. Stat 2-prop z-test. Okay, X1 46, N1 is 145, X2 is 40 men out of 140, and we need to check if P1 is bigger than P2. Okay, Z is 0.58, and look at the p-value, guys. It's a huge 0.2811. Once you see a huge p-value, you fail to reject HO. Wow, I didn't intend that all problems will end up failing to reject HO. I just selected those problems. So there is not enough evidence at the 0.05 level of significance to support the claim. And for the sake of time, guys, that I'm just going to say it verbally, that women are more likely to remember their dreams than men. You just write it down. That's a claim. Just copy it and paste it. Okay, so that's number 17. Okay, we got 4 more questions, and that should be it. A local eat-in pizza restaurant wants to investigate the possibility of starting to deliver pizzas. The owner of the store has determined that home delivery will be successful if the average time spent on the delivery does not exceed 31 minutes. The owner randomly selected 20 customers and has delivered pizzas to their homes in order to test if the mean delivery time actually exceeds 31 minutes. Suppose that the p-value for the test was found to be 0.0278. State the correct conclusion. So guys, this should be a very easy question. He wants to compare this p-value with this alpha. If the p-value is less than alpha, we reject HO. If it is bigger than alpha, we fail to reject HO. So if alpha is 0.025, do you guys agree with me that 0.0278 is bigger than alpha? So we fail to reject HO. So that is true here. 0.0278 is bigger than 0.025. That means we fail to reject HO. Okay, so that's the correct answer. Turns out to be A. 19. A local tennis pro shop string tennis rackets at the 10 pounds per square inch requested by the customer. Recently, a customer made a claim that the pro shop consistently strings rackets at lower tensions on average than requested. So they're not doing it as it should be done. To support this claim, the customer asked the pro shop to string 15 new rackets at 43 psi. Suppose that the two-tailed p-value for the test described above is 0.07. Give the proper conclusion for the test. Use alpha 0.05. So if you guys compare 0.07 to 0.05, do you guys agree with me that the p-value is bigger than alpha? Because 0.07 is bigger than 0. So we fail to reject HO. And if you fail to reject HO, guys, you say there is not sufficient evidence to support the claim. And here you go, right here. There's insufficient. It says insufficient evidence, means not enough evidence. Okay, that's the conclusion. Number 20. Okay, you notice, guys, that I haven't done any questions from 7.2, so it's coming right now with sigma is known. So number 20. The health of employees is monitored by periodically weighting them in N. A sample of 54 employees, so that's N, that's 720, has a mean weight of 183.9. So N is 54. X bar, guys, is 183.9 pounds. Look, guys, what it says here. Please pay attention. Assume that sigma is known to be 121.2. So sigma. And now we know it's a z-test, guys, because he gives me sigma. Now we know when to use a z-test. Use a 10% significance level to test the claim that the population mean is less than 200 pounds. So a student was asking me, how do I know where the claim is? Less than is this sign. And this sign is in the alternative, then the claim is in the alternative. So HO. So you have to put less than in the alternative. Don't put it in the null because he says it first. That should be in the alternative. And the null will be this. All right. And that's a z-test, guys. We know why, because he gives us sigma. And let's do this. Stat. Tests. It's the first test on your calculator, guys. Z-test. Not data. I have a summary. mu0 against 200. Sigma, what did he say sigma was? 121.2. X bar, he says it's 183.9. N is 54 and less than. Okay, Z is negative 0.9798. P-value, again, we fail to reject the null hypothesis. 4.5. That's bigger than alpha, guys. Fail to reject HO. There is not enough evidence to support the claim. At the 0.01 level significance to support the claim. The students are wondering if we reject HO, let's say the p-value, guys, was 0.052, and you reject HO. If this was 0.052, that's less than 10%, reject HO. What do you say? There is enough evidence at the 0.10 level of significance to support the claim. So the only difference is this. But it makes a big difference. Instead of saying yes, you're saying no, guys. You can't just say, oh, I only missed one word. It does change the meaning of the entire question. And the last one, you notice, guys, that I did not do section 8.1, and that's the last one right here. That's going to be 8.1. Then we'll have covered every single section. A study is done by a community group in 2 neighboring colleges to determine which one graduates students with more math classes. College A samples, so A and B, college A, N1 is 25 students. Their average is 4 math classes, so X1 bar is 4. And you guys, can you read it? It says with a population standard deviation of 1.5, so it's a sigma 1. Once it says population, it's a z-test. College B. How many students? 21 graduates. Average is 3.5, so X2 bar is 3.5. And look what it says now. With a population standard deviation of 1, so sigma 2 is 1. The community group believes that the students who graduated from college A has taken more math classes on average. Both population have more normal distribution. Test the claim at the 5% significance level. You guys, you should agree with me. More math classes means mu1 greater than mu2. More, that's the claim. mu1 is less than mu2. And guys, this is called 2-sample z-test. We don't need a pooled for the z-test. You will see it doesn't ask you for this. 2-sample z-test. Okay, let's run the test. And that would be it for this test. Okay, input. See, sigma 1 and sigma 2. It's asking you for sigma 1 and sigma 2. 1.5. Sigma 2 is 1. X1 bar is 4. N1 is 25. X2 bar is 3.5. N2 is 21. And we need more than. Again, guys, if you're asking how did I figure this out, it says college A has taken more math classes than college B. That's how we figured it out. And you want to hit calculate. And okay. Z is 1.34. P-value is, you know what, guys, I just want to make, because I want to reject HO this time, I want to change this one to 10%. So test the claim at the 10%, just to make it work. So the p-value is 0.0889. And you guys agree with me, this is less than alpha, which is 10%. I changed it to 10%, just to end it with the rejection of HO. So reject HO. And the conclusion, guys, there is, I know probably you're tired of me putting no, not enough evidence. So there is enough evidence at the 10% level of significance to support the claim. Now we are supporting the claim that college A students has taken more math classes than college B students. Okay, so that concludes the review. And again, guys, I changed this to 10%. So in the answer key, it's 5%. It's going to be fail to reject HO, but I just changed that. So be aware of that. if you check the answer key. Before I email you this, I will just make changes in the answer key just to reflect on that. But the original one that you received by email has the 5%. I just changed it to 10%. Just be aware of that.